Hey guys, in the last video we actually looked through a little bit of the history of the atom. And when we went through the history of the atom, we kind of looked to see where did we start in chemistry versus where are we, not even today, but where are we in history as far as protons, neutrons, electrons, what do we think an atom looks like, things like that. So just to kind of summarize that real quick. Democritus was the first one that had the hypothesis of an atom. He called it an atomos. He would have drawn it like this. It's just a tiny indivisible little particle. He would have just drawn it a sphere like this. They are 3D. Then the next person to come along was Dalton. He had Dalton's atomic theory. With Dalton, again, he kind of summarized Democritus's idea. So he would have had a small indivisible particle, no guts inside of it. It's not divisible. Then the first person that kind of looked to see what was inside of the atom was J.J. Thomson. He was doing the cathode ray test, and with the cathode ray test, he figured out that there are negatively charged particles inside of the atom called the electron, and so he was the first one to discover that atoms are divisible. After that, we had Ernest Rutherford. Rutherford discovered the nucleus of the atom using the gold foil test. Inside of the nucleus of the atom, he figured out that we have these positively charged little particles here that he called the proton. So he discovered the nucleus and he discovered the proton. The electrons are still scattered just all throughout the atom. There's no rhyme or reason as to where they are. Then next, we had James Chadwick. James Chadwick was the first one that discovered that there was something else inside of the nucleus. With that other substance inside of the nucleus, he called it a neutron because they were neutrally charged. They're about the same size as a proton. And then we still have the electrons all scattered throughout. So we don't have any rhyme or reason or numbers as far as how many electrons are there. So what we're going to do today is we're going to go back to 8th grade science and we're going to figure out how many protons, neutrons, and electrons are inside of an atom. So the first thing that we're going to look at is just the periodic table. And with your periodic table here, this is just hydrogen's element symbol from the periodic table itself. This number up here, the number 1, we called it the atomic number. The atomic number is actually defined as the number of protons in an atom. We're going to find out why in the periodic table next unit, but for right now we just need to know that the atomic number is the number of protons. So if we want to find out how many protons are in something, all we're going to do is we're going to look up the atomic number that tells you the number of protons that are there. Now, as far as the number of protons in an atom, you cannot change it. If you change the number of protons that are inside of an atom, you are changing the element that is present. So if you have 1 proton inside of an atom, you have hydrogen. If you have 2 protons inside of an atom, you automatically have helium. If you have 3, you automatically have lithium. So if you have lithium and somehow you go through a nuclear change and you change the number of protons that are there, and let's say now you have 2, you changed lithium into helium. So the number of protons cannot change for that element. That will always, always, always stay consistent, which is why it's the atomic number. Now, protons are positively charged. Electrons are negatively charged. They have to cancel each other out. You have to have the same number of positive charges and negative charges. So because we have to have the same number of positive charges and negative charges, for right now, we're going to put an asterisk there. To maintain that no charge, there has to be the same number of protons and electrons. So once you find the number of protons, the electrons are going to be equal for right now. That's because positive and negative cancel each other out. Now, to find the number of neutrons, you're going to have to find the mass number from the periodic table. The mass number on the periodic table is actually the atomic mass rounded to the nearest whole number. So you're going to have to go back to 3rd grade and look at rounding again. You don't just lop off the decimals. You actually have to round it fairly, like you're supposed to from math class. Once you round that to a whole number, then you're going to take the mass number and subtract off the atomic number. And that is because a proton and a neutron are the same in size. They're very, very, very big. So because they're so big, The whole mass of the atom comes from the protons and the neutrons. The electrons are so tiny, they don't matter in terms of the mass. It's kind of like, I always give the analogy, let's say that I go to the doctor, and when I go to the doctor says, you weigh, I don't know, I'm just going to round number, 200 pounds. And I go, whoa, whoa, whoa. I don't weigh 200 pounds. There's no way I weigh 200 pounds. Let me get stuff out of my pocket. So I start digging through my pockets. And when I dig through my pockets, all I find is a little piece of pocket lint. I go, oh, I got to get this pocket lint out of my pocket. I put it down and I throw it in the trash can. I get back on the scale. My mass is going to be the same. So as we look at the atomic mass, there are electrons there, but their mass is so insignificant, it doesn't matter. So when we're going to find the number of, or your mass number, it's the protons plus the neutrons. So therefore, in order to get the neutrons, you're going to take the mass and subtract off the number of protons, which is the atomic number. So I have some practice here, and I actually printed this paper with a periodic table, so I'm going to switch over to my document camera here. So with my document camera here, I also have a periodic table that we're going to use to refer to. But this is the slide. Nope, that is not the slide. This is the slide that you guys had on that paper. So with the directions here, it says find the number of protons. This is a way of simplifying the word proton. It's just a letter P. Protons have a positive charge. So if you want to write the word proton small or shorter, I guess, you would take your positive sign and put it after the P. Neutron is neutrally charged, so it's N with a 0. And then electron has a negative charge, so it's E with a negative. So it wants us to find the number of protons, the number of neutrons, the number of electrons. I'm just going to make a little chart here. Protons, neutrons, electrons. So I have sulfur, I have lawrencium, and I have Sc. So I'm going to go to my periodic table and I'm going to find sulfur's information. When I find sulfur's information, it's right here on the periodic table. Sulfur is number 16, and I need to take this mass and I need to round it to a whole number. So when I round that to a whole number, 32.066, that is going to round to just 32. So take that number, round it to a whole number. When I was talking about rounding rules, if you have something like boron down here, boron is 10.811. That 8 makes the 10 go up to an 11. Carbon is 12.01, so I'm going to take the 12 and that's just going to stay the same. So we're going to have to use rounding rules to round all of these off. Something like fluorine down here, 18.998, that's going to round to an even 19. So you're always going to round this to a whole number to get your mass number. So sulfur is number 16, its mass is 32. So I'm just writing that down so I have that information there. Here, I'm going to write down mass. So my number of protons is the number from the periodic table that's called my atomic number. So my atomic number is 16, so I have 16 protons. If I have 16 positive protons, I have to have 16 negatively charged electrons because their charges have to cancel each other out. Now for my neutrons, I don't need to see this work, but you're going to take your mass number, which is 32, minus the atomic number. 32 minus 16 is 16. So on this one, we just so happen to have the same number of protons, electrons, and neutrons. That doesn't always happen. Now with your number of neutrons here, it does have to be a whole number. You cannot have 0.02 of a neutron. You either have a neutron there or you don't. So when you have all your answers here, it's always going to be a whole number. Now for lawrencium, you're going to do the same thing. For lawrencium, you're going to go to your periodic table. And when you go to your periodic table, lawrencium is going to be covered up on my picture over here. So when we go to lawrencium is number 103. Its symbol's Lr, and its mass is 262. So I'm going to write that information down just so I have it handy and ready to go. It's number 103. its mass is 262. So what we're going to do here is we're going to look at your number of protons, which is the atomic number on the periodic table. So I have 103 protons. If I have 103 protons, we also have 103 electrons because those two have to cancel each other out. For my number of neutrons, I'm going to take my mass, which is 262, minus my atomic number, 103. So when we go to subtract these two numbers, you're going to end up with 159 neutrons. So my mass comes from my protons plus my neutrons, so add these two together, you should get 262. And then my electrons are so small they don't matter. Now SC, that's going to be scandium, it's up here. For scandium, I'm going to take my mass and round it to a whole number. So 44.96, that's going to round to 45. So scandium is number 21 on the periodic table. Its mass number is 45. So what we're going to do here is we're going to first start with my number of protons, which is 21. If I have 21 protons, I also have 21 electrons. For my neutrons, I'm going to take my mass and subtract off my atomic number. 45 minus 21 is 25.